Of third prep. Today we are going to start our new lesson, which is the main trigonometric ratios of acute angles. Main trigonometric ratios of acute angles. It means that we are going to talk about ratios, and our angles will be all acute angles. First of all, then, if you have triangle ABC, right angle triangle at B, then the longest side of the triangle is called hypotenuse. What is hypotenuse? It is the side opposite to the angle of measure 90 degrees. And it is always the longest side of the triangle. So, if you look to the opposite figure, measure angle B is 90 degrees, so we can say that the hypotenuse is AC, and it is going to be the longest side of the triangle. Then, if you have measure angle C greater than measure angle A, so we are going to say that there is a side longer than another side. The side opposite to the greater angle is longer than the side opposite to the smaller one. So in this case, we can say that AB is longer or greater than BC. So AB is the longer, BC is the shorter. If you have the ratio AB over AC, it is going to be less than 1. As a small value over a big value, the value will be smaller than 1. But what about AC over BC? Yes, a large value over a small value, so the answer will be greater than 1. What about if you divide the two ratios, AB over AC, divided by BC over AC? It is going to be equal to AB over BC. Then what about the addition, their addition? If you are going to add AB over AC plus BC over AC, you have the same denominator, so you can add. And you know from the previous year that the length of any two sides of the triangle must be longer than the length of the third side. So AB plus BC is longer than AC, so a greater value over a smaller value, so the answer will be greater than 1. What about the circular measure of the angle? All of you know from first prep that the sum of the measures of accumulative angles about a point equals 360 degrees. All of you know it. And you also know that you measure the angle with the degrees. But if we divided the degrees into 60 equal parts, each part is going to be called minute. And if you divided the 1 minute into 60 equal parts, each part will be called second. So we can say that 1 degree equals 60 minutes and 1 minute equal 60 seconds. Then, if the measure of the angle is 50 degrees, 35 minutes, 20 seconds, so it is read as 50 degrees, the sign of the degrees, 35 minutes, which is the dash, 20 seconds, which is the double dash. Or it can be written as decimal form as 50.58888. How can you find it? Using your calculators, of course. You are going to press 50 degrees, 35. Instead of minutes, you are going to press the bottom degrees also, 20 degrees also instead of seconds, and you are going to do to press equal, So you are going to obtain a result in the decimal form, which is written as 50.58888. Then have an example. Write in minutes and seconds. 28.4 degrees. How can you write it in the form of minutes and seconds and degrees and so on? By using your calculators. Write on the calculator 28.4 degrees, then press equal, then press the bottom degrees. You are going to obtain a result as 28 degrees, 24 minutes, and as in the form in front of you. What about 64.78 degrees? You are going to write it on the calculator, press the bottom degrees, then press equal. You are going to obtain a result as 64 degrees, 46 minutes, 48 seconds in the form written in front of you. Then, what about the main title of the lesson? It is main trigonometric ratios of acute angles. So, what about the trigonometric ratios of the acute angles? First of all, if you have triangle like that in front of you, it is a right angle triangle. Then you have an angle called theta, which is angle C. I'm going to symbolize it as theta. When you look carefully to angle theta, you are going to find that there is a side opposite to it, a hypotenuse as it is a right angle triangle, and a side adjacent to this angle. What's the meaning of adjacent? It means the side beside this angle. Someone asks, there are two sides beside this angle, theta, which are AC and BC. No, I'm going to tell you that AC is the hypotenuse, not any other thing else. So what about the adjacent, the side beside the angle? It is the side BC. So when you have angle theta, you are going to notice that the side opposite to it is AB. Then the adjacent is BC, and AC, of course, is the hypotenuse. Then we are going to find three main trigonometric ratios. The first trigonometric ratio is called sine. So to find the sine of the angle theta, it is opposite over hypotenuse. This is the rule of the sine theta. It is the side opposite to it over the hypotenuse of the triangle. It means to find the ratio of sine theta, you are going to find its opposite side divided by the hypotenuse of the triangle. This ratio will be called sine theta. We have three trigonometric ratios. This is the first one. What about the second one? It is a ratio called cosine theta. Its rule is adjacent over hypotenuse. So what about cosine theta? It's adjacent over hypotenuse. What about the third trigonometric ratio? It is called tan theta, and its rule is opposite side over the adjacent side. So sine is abbreviated as SOH. What is SOH? The first letter of the word sine, the word opposite, and the word hypotenuse. SOH, S-O-H. It is abbreviated as SOH, so as to remember the rule. Sine equals SOH, opposite over hypotenuse. What about cosine? Take the first letter from each word, so it is K. What is K? Yes, it is C-A-H. So it is K. And what about the tan? try to pronounce, it is T-O-A, the first letter of every word. So it is to, which you always say in your homes. Then it is to, so, ka, to. Take good care. Then let us have some examples. ABC is right angle triangle at C. AB equals 10 centimeters, BC equals 8 centimeters. Find the length of AC and also find all trigonometric ratios of angle A and angle B. Look carefully. You have right angle triangle. You know the length of AB and BC. And measure angle C equals 90 degrees. Now, can you find the length of AC? Yes, of course. How? By using Pythagoras theorem. So, we can here prove that also sine A cosine B plus cosine A sine B equals 1. Try to find first the length of AC. That's correct. You have triangle ABC. So you are going to find the length of AC as it is the length of a side, not the hypotenuse. So we can say that AC to the power of 2 equals AB to the power of 2 minus BC to the power of 2. So it is 10 to the power of 2 minus 8 to the power of 2 to give a result as 36. Now AC to the power of 2 equals 36 by taking square root for both sides. So you are going to find that the length of AC equals root 36 to give a result equals 6 centimeters. Now you have the length of the three sides, AB, BC, and AC. Can you find all trigonometric ratios? What are the trigonometric ratios? It is the sine, cosine, and tan. For which angle? Either A or B. I want both of them. So let us first start to find sine angle A. Yes, sine is so it is sine equals opposite over hypotenuse. But what angle? It is angle A. So sine angle A equals opposite over hypotenuse. What is the length of, or what is the side opposite to angle A? It is BC. And what is the hypotenuse? It is AB. So we can say that sine A equals, that's correct, BC over AB, which is equal to 8 over 10. Then by cancelling or reducing, you are going to find the result as 4 over 5. Then what about cosine A? That's correct, it's kah. So it is adjacent over hypotenuse. What about the adjacent of angle A? It's AC, which is of length 6 centimeters. And what about the hypotenuse? It is of length 10 centimeters. So it is 6 over 10 equals 3 over 5 after reduction. Can you now find 10A? What about 10A? It is top. T-O-A. So 10 equals opposite over adjacent. What about the opposite side to angle A? It is 8. What about the adjacent? It is 6. So it is 8 over 6. After reduction, you are going to obtain a ratio as 4 over 3. These are the main trigonometric ratios of angle A. By the same way, can you find the 3 trigonometric ratios of angle B? Of course, yes. How? By the same way. You are going to find sine B. What about sine? Opposite over hypotenuse. So it is, that's correct, it is 6 over 10 to obtain after reduction a ratio as 3 over 5. Then what about cosine B? Yes, that's correct. It's adjacent over hypotenuse. So it is going to be 8 over 10, and after reduction it will be 4 over 5. What about 10b? It is opposite over adjacent, which is 6 over 8 to obtain a ratio as 3 over 4 after reduction. Then you want to prove that sine A cosine B plus cosine A sine B equals 1. You have found sine A. What about sine A? That's correct. It is 8 over 10, which is 4 over 5, multiplied by cosine B. What about cosine B? It is also 4 over 5. Plus, what about cosine A? That's correct. It is 6 over 10, which is 3 over 5, multiplied by sine B, which is 6 over 10, after reduction 3 over 5, to obtain a result as 1 by using your calculators. Let us have another example. XYZ is right angle triangle at Y. Measure angle X equals 45 degrees and XZ equals 10 centimeters. Find sine 45 degrees. First of all, when you look carefully to such an example, you have measure angle X equals 45 degrees. This means that this triangle is what? That's correct. This triangle will be isosceles triangle. Why? Because since XYZ is right angle triangle at Y, and you can find measure angle Z. How? Yes, it is 180 degrees minus 90 degrees plus 45 degrees to obtain a result as 45 degrees. So this triangle is going to be an isosceles triangle. And in this case, isosceles triangle means that you have two sides equal in length. What are they? Yes, they are XY and YZ, as XZ is the hypotenuse, which is the longest. So in this case, we can say that XY and YZ are equal in length. Now, you are going to think carefully. Can you find it? Of course, yes. XZ to the power of 2 equals XY to the power of 2 plus YZ to the power of 2, which is the rule of Pythagoras theorem. Then you are going to find that XY equals YZ, then XZ to the power of 2 equals double YZ to the power of 2. And in this case, we can say that 10 to the power of 2 equals 2YZ to the power of 2. By dividing both sides by 2, you are going to find that that's correct. You are going to find that YZ to the power of 2 equals 50. And by taking square root for both sides of such an equation, you are going to find that YZ equals root 50, which is equal to 5 root 2 centimeters. Then you have obtained YZ as 5 root 2. Then, can you find sine 45 degrees now? Of course, yes. The two sides are equal, 5 root 2, 5 root 2. So sine 45. What about the sine law? Yes, sine is opposite over hypotenuse. So sine 45 equals the side opposite to the 45 degrees over the hypotenuse of the triangle, which is equal to 5 root 2 over 10 to obtain a result as root 2 over 2. Then let us have another example. LMN is right angle triangle at N. like that shown in front of you in the figure. And the length of LM equals 13 centimeters and NM equals 12 centimeters. And I want you to find tan L. What about tan? Its law is opposite over adjacent. Then when you look carefully at angle L, its opposite side is MN. What about its adjacent? It's LN. Do you have or do you know the length of LN? Of course not. How can we find the length of LN? By using Pythagoras theorem, we can find that LN to the power of 2 equals LM to the power of 2 minus NM to the power of 2. By substituting, you are going to find that it is 13 to the power of 2 minus 12 to the power of 2 to obtain a result as 25. By taking square root for both sides of the equation, you are going to find that Ln equals square root 25 to give a result as 5 centimeters. Then, what about tan L? Tan is opposite over adjacent. It's a ratio of opposite over adjacent. What about the opposite to angle L? It's 12 centimeters over 5 centimeters to obtain a ratio as 12 over 5. Let us have another example. ABC is triangle in which AB equals AC equals 10 centimeters and BC equals 12 centimeters. Then draw AD ray perpendicular on BC line segment where AD ray intersect BC line segment at point D. Then try to find the value of sine angle CAD and cosine angle CAD. Then prove that sine square C plus cosine square C equals 1. Now, let us see how can we find these requirements. At the very beginning, you have triangle ABC, which is isosceles triangle, as there are two equal sides, AB and AC. Each of them equals 10 centimeters. Then, as these two sides are equal, and as AD is perpendicular on BC, so we are going to notice that, yes, corollary, which we have studied before, says that BD will be equals to DC. So as the perpendicular drawn from the vertex angle of isosceles triangle bisect its base. So we can say that DC equals 12 divided 2, so equals 6 centimeters. Then you are going to notice that the length of DC equals 6 centimeters. Now, in triangle ADC, you are going to find sine angle CAD. What about angle CAD? Its opposite side is DC, and its hypotenuse is AC. So sine angle CAD equals opposite over hypotenuse, which is DC over AC, which is equal to 6 over 10, to obtain a ratio as 3 over 5 after reduction. Then, in triangle ADC, yes, you are going to notice that AD to the power of 2 equals AC to the power of 2 minus DC to the power of 2, which is equal to 10 power 2 minus 6 to the power of 2 to give a result as 64. And by taking the square root to both sides of the equation, you are going to find that AD equals square root 64 to obtain a result as 8 centimeters. Yes, I want you to find cosine angle CAD. What about the cosine? That's correct. It is adjacent over hypotenuse. So cosine angle CAD equals adjacent over hypotenuse, which gives a result equal AD over AC, which is 8 over 10. And after reduction, you are going to obtain a ratio as 4 over 5. What about sine square C plus cosine square C? Yes, of course. Look carefully. What about sine C? It is opposite over hypotenuse. So we can say that sine square C plus cosine square C equals AD over AC, which is the rule of the sine, opposite over hypotenuse. But I want you to find sine square. So AD over AC, all to the power of 2. Plus, what about the cosine C? Cosine C means adjacent to angle C over the hypotenuse. What about the adjacent of angle C? It is DC over the hypotenuse, which AC. And as I am asking you about cosine square, so DC over AC, all to the power of 2. By substituting with the values, what about AD over AC? It is 8 over 10, all to the power of 2, plus 6 over 10, which is DC over AC, all to the power of 2, to obtain a result equals 1, which is the second required. By the end of this example, we have reached the end of our lesson today. I wish that all of you understood this lesson, and we'll meet next lesson, inshallah. Bye-bye.